The next topic, we have a balanced Wye-Delta circuit. We have a balanced Y source, a balanced delta load. If you look at this figure, we have new variables. We have IAB, IBC, and ICA. So IAB, IBC, and ICA are what we call the phase currents of the delta load. So for example, we have one line voltage of a balanced Y connected source is VAB equivalent to 120 with an angle of negative 20 degrees. If the source is connected to a delta connected load of 20 with angle of 40 degrees ohms, find the phase and line currents. So assume the ABC sequence or the positive sequence. We have, let's label this as IAA, IBB, and ICC. What is given is the voltage VAB. We have, so if this is VAB, lowercase VAB, this is just equivalent to the uppercase VAB. Because if you look right here, this branch right here just in parallel with phase A and phase B, or line A and line B. So VAB is just equivalent to VAB is 120 angle negative 20 degrees volts. If Z delta is equivalent to 20 angle 40 degrees ohms, find the phase currents and line currents. We can easily find the phase currents. So assuming the positive sequence, so positive sequence, we have VAB equivalent to 120 with angle of negative 20. BBC, so it's just the same with VAB, but it is lagging by 120 degrees. So this is negative 140 degrees. And then we have VCA equivalent to 120 over 100. 120 angle 100 degrees. Oops. So looking at the figure, we can directly solve for IAB, IBC, and ICA. So we have IAB that's equivalent to VAB over Z delta. We have 120 angle negative 20 over 20 angle 40. So this is equivalent to 6 angle negative 60 amperes. Now if it is balanced, remember if it is a balanced system, you can get the value of one component and then we can relate that component to the other components. So in this case, we can relate IAB to IBC and ICA. So IBC is equivalent to IAB. It is lagging by 120. So this is equivalent to 6 angle negative 180 degrees amperes. And ICA equivalent to IAB, then add the angle by 120. We have 6 angle 60 degrees amperes. Or you can get IBC and ICA the same way we got IAB. So we have equivalent to BBC over V delta. Then ICA is just equivalent to VA over V delta. So either of these steps, we will arrive with the same answer. If we get the phase voltages from the line voltage, what we need is you divide the magnitude by square root of 3 and then subtract 30 degrees from its angle. We have negative 50. Okay. So same goes with BBN and BCN. So line current IAA equivalent to square root of 3 IAB. Then you subtract the angle by 30. Is equivalent to 10.392 angle of 390 degrees. So IBB, ICC is equivalent to this value. And then this 100 degrees out of 120 degrees lagging from IAA. We have negative 110 amperes. So which is equivalent to 10.392 angle of 150 degrees amperes. And lastly, ICC equivalent to 10.392 angle of positive 30 degrees amperes. We have the line currents and phase currents. To confirm our answer, we can use the per phase analysis. So using the per phase analysis, phase we have phase A, we have this is VAN, we have 120 over square root of 3 angle of negative 50. Then we have 20 over 3 angle of 40. And this is our line current IAA. So using per phase analysis, we can get the value of IAA, the line current IAA. We have IAA equivalent to 120 over square root of 3 angle of negative 50 all over 20 over 30 angle of 40. You will see that we will still arrive with the same answer. This is equivalent to 10.392 angle of negative 90 degrees. So you can see is equivalent to value right here, equivalent to the value right here. So for this example, you can get the phase currents and line currents so using this method or using the per phase analysis.